Okay, so today's lesson, we're going to be taking a look at solving nonlinear systems. So basically, we're going to be using exactly the same tools that we did when we were solving linear systems. So the substitution method, elimination method, even graphing if we're given a graph. The only difference is now instead of having two lines, we're going to have something that is not a line. So something like a parabola or a circle. So we'll start off by just reviewing how to solve linear systems. We'll go through this together in class. But again, it is using simply either substitution or elimination, depending on how the problem is set up for us. So as I said, we've already learned how to use substitution and elimination. We're just going to apply those skills and have at least one quadratic in it. And we're then going to have to utilize the techniques that we've learned in the previous sections on how to solve these quadratics. So using the square root method, factoring, the quadratic formula, completing the square if you want to. Those will be utilized to get rid of the square so we can find our x values. Because now we're going to have, as you can see below, one solutions, two solutions, or even no solutions. So just to take a look at what visually they will look like, no solutions, these three right here, you can see they don't cross at all. So what's going to happen is when you start solving, you're going to be left with an imaginary number. And in that case, we're not going to find the I and simplify it. We're just going to say no real solutions. Because remember, the goal of solving a system is, well, where do they meet? Where are these points of intersections? That's the whole point of solving a system. So if it's an imaginary number solution, then there is no solution. There is no real solution. There's no point in which they intersect. We can have one solutions where they're going to be tangents to each other. They're just going to kind of touch once and keep going. Again, whether it's a line, two quadratics, or a circle and a line. Or we can have where they cut through each other and they're going to hit twice. Because if a line cuts through a parabola, it's going to hit the left side, keep going, and then eventually hit the right side. Same thing if I have two solutions on a two quadratics, they're going to hit, and then a line and a circle will also hit in two places. So just to start by graphing really fast, we look again for points of intersection. So if I look at these two that are already done for us, we can see the graph set up. Both of these happen to be tangents. They're touching at one place and then continuing on. So what we're going to be doing in class is we're going to use the Desmos feature, the Desmos.com graphing. We'll graph the two and then use that to help us. Now, again, graphing is not our best option because if it's a decimal, we're not going to be able to actually figure that out visually seeing it, especially if we look at 11, 12, 13, and 14. But it is a useful tool to help us check our work to see if we were at least in the right places. All right, so just by looking at 11 through 14, because these are already graphed, again, where the blue and red meet, in 11, it's going to be at 1 point, and that point would be at -4, +1. So it'd be the 0.41. Number 12, we can visually see there's nothing. They're not touching at all. They're going in their own opposite directions. They're never going to meet. So this would be a no real solution. In 13 and 14, here we have 2 points. We can see that they're crossing in two different places. So we would have two ordered pairs. So for 13, we would have the 0.14 and then 6, 8, probably 9, 4, it looks like in this last one. Okay, and then 14 will do the same thing. So that would be using our graphing method. Now, what we're mostly going to be utilizing is substitution or elimination. So the first thing we're going to take a look at is substitution. With substituting, you are going to always substitute your y. It's just going to make your life easier because if we try to substitute in for x's, notice we have a lot more x's involved. There's going to be a lot more things to substitute. And it's just going to make it a little bit harder because you'll have to FOIL things if I plug something in for the x squared. And we want to make our life as easy as it can. So I would highly suggest always get your y alone. Use that for your substitution. And you can follow what I did. So I took the red, got it to y equals, plugged it into the blue equation, and then simplified it. Okay, when we solve, or when we get down to it, we have a quadratic. You can then choose whatever method you want. I chose to do factoring. It was easy enough to factor. Factors of -3 that add to 2 are 3 and a -1. So to me, that was really quick. If you don't like factoring or you're still struggling with it, then use the quadratic formula. You can always use the quadratic formula with any quadratic to solve. But now the thing to remember is if I have two x's, that means I have 2 points of intersections. I need to find both ordered pairs. So then you just plug each of them back into your y equals, and you get your 2 ordered pairs. So in this case, we have -3, 7 and 1, 3. Just like when we had our substitution in linear functions, you always want to write it as an ordered pair. Just in this case, with a quadratic, we might have 2 ordered pairs. The second one shows substitutions of a circle. So you're not going to have to create the circle equations. They'll be given for you, as you can see down here, x squared plus y squared equals 10. But just if you want to know where it comes from, a circle with the center at the vertex of 0, 0 with a radius of r is in the form x squared plus y squared equals r squared. Okay, the r being however long your radius is. All right, so we have 2 equations here. One's a circle, one's a line. We're going to take our y equals, substitute it in, right? I already have y equals, so I plug it into the y squared. You do have to FOIL this one because the y is squared, so you write it twice, multiply it out if you need to do the work on the side. This is what you're going to end up with. And then you combine your like terms, again, get it to a point where you can solve. Again, I chose factoring here, factors of 9 that add to a -6 or a -3. Now you're going to have 2 answers, but they're identical. When I saw both of those factors, x is equal to 3 in both of them. So I don't have to write it twice. If they're identical, plug it in, you get your y. Okay, so in this case, there's only one solution because of the fact that the 3 repeated. So we'll go through these examples together in class, but you have those 2 already done that you can look at. The last one we're going to take a look at is elimination. So elimination is just like it always is. Our goal is to get something to cancel out. So our goal is to always eliminate the y, because if I try to eliminate an x squared or a single x, I am then left with 2 different variables. I'll have an x and a y still. So I want to cancel out the y so that way I'm only left with x's. So if they're already opposites, like we see here, add them together, cross them out. If one of my y's had a coefficient, then I have to multiply to cancel out. But again, we always want to eliminate the y. That's what I want to stress over here. Again, choose an appropriate method and go ahead and solve it. So in this case, I couldn't really factor it. So I chose to use the quadratic formula, right? So if I plug it all in, I could find the discriminant first. The discriminant ended up being -15. So I would have known from my discriminant that I have an imaginary answer. I have no real solutions. So when I'm solving these and I come across something that's going to give me a negative inside a radical, an imaginary number, you do not need to simplify any further because we know that there is no point in which these 2 lines will intersect because of the fact that it's imaginary. Okay, so again, because we're looking for a point of intersection, we're trying to solve a system. That is why we stop. If we were just solving a normal equation, we would want to simplify it. So please be aware of what they're asking you to solve for, right? And again, we'll work our way through some examples together in class, including some word problems, okay? So again, watch this video, go through the slides as many times, take a look at the examples that I did out for you already. We'll be utilizing those to go through each example in class.